Hi, good morning, everybody. Welcome to today's Rubin Science Assembly. Hello. Today we're going to cover a little bit about preparing for the start of alert production and then also a couple of notebooks that access commissioning metadata. So we'll start as always with some announcements, then we'll do a couple of slides on getting ready for alerts. There'll be time for questions on that, and then we'll switch into the notebook aspect of the Rubin Science platform and work through a couple of tutorial notebooks. All right, to start with announcements, Bob posted a nice Rubin update that corresponded with the AAS 247 back in January. It's on the Rubin Community Forum, and there's a whole slide deck there that kind of just goes over recent progress with Rubin. And it's the same slide deck that was presented at the Noir Lab Town Hall. There's also early operations updates every Friday from Keith Bechtel. They also get posted in the Rubin Community Forum news category. A couple of weeks ago now, new FITS files were released for DP1. The actual pixel data is not different, only the headers changed, and they only changed to avoid errors with the FITS approximations of the WCS. If you didn't notice the errors in the first place, you probably also won't notice any changes, but you can see a summary of those changes there in the forum. Along with those updates of the FITS files, the web dev file upload limit increased from 100 megabytes up to 2 gigabytes. And so that should help you out if you're trying to move a lot of files in and out of your notebook aspect home directory. The LSST Discovery, sorry, typo, Discovery Alliance. Grant proposals deadline is coming up February 17th. These are fast turnaround funding to support scientific work related to early Rubin Observatory, like the early science program, so the data previews, etc. These grants are open to principal investigators based at U.S. academic institutions whose institutions can accept awards with no indirect costs. So if you want to learn more about that, maybe get a little bit of funding to support a student, support your early science, check out that announcement from the Discovery Alliance. As always, a save the date for the RCW 2026. We're going to be at SLAC July 27th to 31st. And then for upcoming Rubin Science Assemblies, because alert production is expected to start pretty soon, the brokers are preparing to have you as users. So our next science assemblies will feature as many of the brokers as we can fit into the schedule, and they will give you hands-on tutorials. So you can come and you can learn how to use the various brokers. The schedule is not done. We're still adding some more of the brokers to the schedule. So keep an eye on that, and we'll see you in future weeks. As always, standard slide reminder that there is a users committee. It's their job to advocate on behalf of their users. They love to hear from users. They want to know what works for you, what doesn't. They're very open to being contacted, so please do if you have anything to say. And always, we advertise the Link Frameworks office hours. They happen right after this meeting, so they happen at 10 a.m. Pacific. You can drop in, ask them about the software that they are producing, learn to use their tools. I think one out of every four, something like the first Thursday of the month or something like that, is a talk. So you can get up to date on all the great tools that Link Frameworks are developing. All right. Let's switch to our presentation for today, getting ready for alerts. If you are new to Rubin, and if this is your first maybe Rubin related presentation, welcome. Alerts are one of the prompt products that Rubin is going to generate. These are the near real-time data products that are processed within minutes and released within like minutes to days. So there's kind of two time scales for Rubin data products. One is the prompt that's happening all the time, and the other is the annual data releases that we're not covering today. But the alerts in particular, among all the prompt products that will come out, alerts are the ones that are distributed within minutes, and they are notifications of detected sky changes. And we expect to eventually, once the alert stream is at full fidelity, be distributing up to 10 million nights per night. And these alerts, they don't go to individual people, they go to brokers for processing. So the key terms here are alerts and brokers. So I mentioned that alerts are notifications of changes that are identified in real time. How do we do that? You have a new image, also called a science image or sometimes a direct image, and that is the one that just came off the telescope. You also have, you build templates, usually based on past years of data. Of course, Rubin hasn't been going long enough to have templates based on years prior, but so that the templates are all quite recently generated still, but you have a template image that is deeper and is usually built of very good seeing images. And you subtract the template from your science image to create a difference image. And that's the process that you're seeing here on the screen, science, template, and difference. Then you run source detection on the difference image and find all sources, be they positive or negative, with a signal to noise ratio greater than 5, and that is a detection in the difference image. And that is how we identify changes. This series of science, template, and difference is also called a detection triplet or a triplet image. Sometimes these little images are also called stamps, so you might hear those terms used. And in particular, this is an example from Rubin commissioning data for an unclassified time domain event that was also discovered with by the Zwicky transient facility. So that's what we're talking about when we mean identifying changes in real time. And then one alert packet is issued for each difference image source that's detected with signal to noise ratio greater than 5. And again, that source can be positive or negative flux. This particular example is showing a positive flux. The alert itself is basically just a machine readable file, an ASCII file, for example, that contains data for the detected source. So it contains the sky location, like the sky coordinates. It has measurements, the magnitude, the shape, all that kind of stuff. Observational metadata, the date, the time, the filter for the source that was detected. Alert packets will eventually come with a 12-month history of past detections, and these very small image cutouts, the detection triplet, comes with it. Their JSON format, I think, and this is just sort of an example of what it would look like. But you, as the user, you don't really need to know what the guts of an alert look like because the brokers deal with the guts of the alert for you. And as a user, you would just use the brokers to interact with these. But if you do want to know what the guts of the alert look like, it can help you to interpret alert packet data. The schema is available. It's the alert production database schema. You can find it at sdm-schemas.lsst.io. All Rubin schemas are at that one same site. And then /apdb gets you to the alert production database schemas. And again, familiarity, knowing exactly how alerts are formatted, not necessary to use the brokers, but maybe informative, which is why it's here. I will note that the light curve characterization parameters, also called time series features, that are computed after each new detection. So you have one detection in a difference image, and then the pipeline takes that one detection and associates it with other detections that we've seen at the same location. So you can build up a light curve over time of detections of the same static sky coordinates. And then you can do light curve characterization parameters and measure things about the light curve. And so every time Rubin sees a new detection in a difference image for a given location on the sky, it recomputes these light curve characterization parameters, and those also go out with the alert. And my point here is just that what those parameters are is still very much in development, and at this early time, not everything that we plan to put in the alerts and to measure from the light curves is available. If you are interested in exactly what Rubin might eventually include in terms of time series features, there's a tech note, ls.sc/dmtn118 is the tech note that kind of covers everything that Rubin might eventually calculate for those. The other schema that you need even less than the APDP schema is the actual Avro packet, the actual format. Oh, I see a question. Also overlap. Yes, Rob, this is the Avro the packet schema, and so this has yeah, this is exactly how things are formatted inside the alert. So this is probably the one you want. Yep. All right, so I mentioned that alerts are going to start soon. They will be over a very limited region of the sky. The sky regions that will have templates for early alerts are only the deep drilling fields that Rubin covered during science validation. So that's only some of, only I think like 5 of these sort of yellow dots. We'll have more on which field those are in a later tutorial. So very limited area on the sky that alerts will start coming out. New template area is not anticipated to be added to the templates before like late March at the very earliest. So alerts will start, they will only be in the deep drilling field areas, and that's not going to change until maybe early April. You can learn a lot more about the fields that have been covered at surveystrategy.lsst.io, or of course, this RTN 011 is the early science document. And yes, I think I am just going to show you that really quick because at surveystrategy.lsst.io, there is a page called Science Validation Survey Overview. And all of the templates that are being used for alert production all come from the science validation surveys that have been happening over the past, not quite a year now, but since LSSTCAM went on. And in particular, at the end of September, there was a big sort of summary released about all the LSSTCAM visits so that were happened up until this point. And in particular, there is a section of this page that does have the list of deep drilling fields, right? So I mentioned that alerts are only going to start coming out in the deep drilling fields, and this is the place to learn a little bit more. Also, one of the notebooks that we have today will show you how to interact with this data set. And so these are the 5 deep drilling fields that alerts are going to start coming out in. All right, so alerts are coming. They're coming in the deep drilling fields. How do you get to them? Yes, Richard, go ahead.
Right. So on the first night of a detection in deep drilling fields, there could be 5, 10, 20 observations in a row that each have a detection. Will Rubin's DIA be able to make those associations immediately, or are we just going to get 5 or 10 independent alerts, and maybe the next night we'll get information that, hey, those are all connected?
Yeah, it's my understanding that that is a true problem, that immediate association is very challenging to do. And so you might have unassociated alerts. If it's the first night that the DIA source was first detected and a new DIA object got made, but then like 1 minute later you redetect it and it's not, that's not enough of a time difference to be able to associate it. So it still thinks it's new again.
So that
Like
means there'll be redundant DIA objects.
that then, yeah, these are better questions for the AP team than for me, but yes, it's my understanding that this is going to be an issue with like in the first night of detection for deep drilling field objects.
Okay. Yeah, if there's clarity on the second night, it would be useful to spell that out. I mean, not in this tutorial, but in your schema somehow to give an
Yeah,
example of how that gets resolved in the second night.
yeah, yes. Yeah, I don't know exactly what happens. I know Eric knows, and there's been conversation. I just can't remember what it is. What happens to those DI objects that you made in the first night that you now don't need anymore? I don't remember what happens to those. Make sure that gets documented.
Yeah, we're going to have a ton of those. It's not just
Yeah.
going to be an occasional thing.
Yep. I am sorry that I forget. I know there's been a lot of talk about what to do. Okay, I'll follow up on that later. Thanks. All right. So, as users of the alert stream, you are going to be interacting with alert brokers. Alert brokers are independent software systems that process and serve alerts to the community. They are being built independently of Rubin Observatory. So, as a scientist, you access alerts via the broker websites and you can filter on your research area. And as a final note, alerts are world public. Data rights are not required to access and analyze alerts. Over at the lower right here, there's just some nice logos for 8 of the brokers, just 8 of the brokers that have logos. Um, Alert brokers, there are so many because they are quite different. Each offers like a variety of services, and those services are different between the various brokers. This is just one example, a screenshot of the Antares broker. You can go to the Antares website at antares.norlab.edu. And there, the broker interface is open interface. You can log in to have access to some advanced features like creating watch lists, coordinates, regions on the sky where you want to be notified of alerts of interest. You also have to make an account if you want to submit Python code for a new filter, but otherwise you can just go and browse the alert stream. You can filter, which means query or search the alerts database and the alert stream by the number and date of the detections that you're interested in, the sky location, so you can do cone searches for alerts. There's cross-match to popular catalogs has already been done for you. And there are various what they call tags. For Antares uses the term tags based on alert properties such as like alerts that only have high signal to noise ratio, alerts that have a certain color. I believe there's like a red and rising, for example, tag. Alerts that are only getting brighter or only fading, tags based on various variability parameters, all different ways for you to sort of cut down the number of alerts to only the ones that you are interested in. Each of the brokers has their own sort of website. I'm just using this one as an example. Oh, yeah, long-term plan is to enable same-night association, but and that the redundant DI objects are cleared on the following night. Yeah, yes, so still not a lot of detail, but we will make it clearer in the documentation what happens.
Uh, Thanks, that would be great.
Oh, sorry, I'm just noticing another chat question. Uh, Actually, it's my understanding that actually all 3 stamps weren't there, but only 2 because you can make the third. Um, but they will be fits. Yeah. Okay. All right. So there's a bunch of alert brokers out there. How do you choose one? The place to go, we tried to make some resources for choosing alerts, and the place to go is the rubinobservatory.org for scientists web page for alerts and brokers. So let's just pop there first. Rob will come back to that long post in a minute. All right, if you come to rubinobservatory.org, come to the For Scientists webpage. Under data products, pipelines, and services, there's a whole page on alerts and brokers. This is a really good first stop if you're just starting to get familiar with what is an alert and what is a broker. So you come here and you can read about the alert stream and the contents of the alerts, how they're made, all the basics that I just covered. And then we do have a section here on alert brokers. This just describes what they are in general. And then every alert broker has written a little summary. So this is a good place to come and start, read the various broker summaries, browse the various broker web pages, and try out their resources and see if they will work for your science. So the brokers wrote the content that's on that page, and they want you to realize that integrating a broker's services into your scientific analysis, it can take a significant time investment. Alerts are not a simple data product. Brokers are not a simple tool. But you do want to just sort of start easy, learn about a broker's tools, interfaces, and science applications, and then sort of iteratively build up your scientific analyses of LSST alerts using the brokers. So as I mentioned, your first step is to browse the broker's documentation and web-based user interfaces, test out the brokers, test the tools that the brokers offer. The brokers, most of them, I think, have been running with CTF alerts, so their tools are fully formed. You can, for example, use the broker to try to identify subsets of ZTF alerts that might match your science goal. It will work the same way with LSST. There'll just be a lot more alerts. And then the brokers invite you to engage with them, ask them questions. If you can't find a tool or a resource that you need for your science, let them know. They are still developing their tools as well. And they are all very friendly people who are very eager to hear from the users and to work with you. And as a reminder, the upcoming Rubin Science Assemblies will feature broker tutorials. There is a new public dashboard for Rubin Alerts that is up. It's at alice.st/alertstream status. You can go there right now on your laptop. This is just a screenshot from Tuesday when I made these slides. This page of like whether the alert stream is up or not is more so the brokers have a place to check on the status of the alert stream, but you might find it useful as well. So you can check that out. And right, that was the bare minimum sort of to get you aware that alerts are coming and with some resources to follow up on so that you can take action to start to use a broker and start to use alerts. I'm going to do raise your hand if you have a question, and I'm going to scroll back in the chat and okay. Yeah, it's that problem where on night one you have two detections that are then don't know about each other and they're each given a DI object. But then on the second night, which of the DI objects is discarded? Yeah, we'll have to write that process in the documentation. Just isn't there yet. Yeah, Rob, well, this is the same question, so we'll get you the answer for that.
Yeah.
And it'll
I
be
have a
documented.
related question.
Hmm.
Um, I remember from a few months ago that the PPDB was not going to be available, at least in the first year. Is that still true?
It should be available later this year.
Yeah. Okay.
Yeah, yep, yep. So it will be available, yeah, this year. You don't have to wait a year for it.
But not right away. Yeah.
But not right away. Alerts first, and then it will be a good few months before the PPDB is online and queryable. And so for those that don't know, prompt products database is the queryable set of catalogs that have the same contents as went out in the alerts, but they are saved in queryable databases that you can access via the Rubin Science platform. Very similar to like the DP1, DIA object, DIA source, DIA force source tables that you can query through the RSP. But it's the same data as went out in alerts. And collectively, we call that the prompt products database or PPDB. Okay, so they are doing all three. Okay, all three FITS files. Great. Is the matching guaranteed to be resolved next night, or do we have to wait for next detection at that location? I think you would need at least, yeah, I think I personally can't guarantee that things will definitely be resolved the next night, but that is the right time scale. I don't think you need detections on a second night. to resolve that. No.
For
There have been
Killanova, there
lots.
may never be a second night, but we won't get one in the DDF. So
Yeah. And then Rob's question is, how do you know what the decision was? Mm. Yeah, Rob, you're right. The alerts, the brokers wouldn't know that one of the DI objects has been discarded unless another alert goes out. That's true. Thad, you can always make posts on community. Is that for a question?
Yeah, I think that might be a good way for us to get the answer to these questions to the community, right? So
Oh, yeah.
perhaps one of the people who are asking may want to make a post on community so we can follow up there.
Yes, absolutely. You can always do that, but I also will take it away as an action item to make sure that gets into our prompt products documentation, which is currently being written and has like all the information about alerts. But posting on community is a much more secure way to make sure that happens. So yes, please. Always post on the forum. Always, always helpful. The PPDB will not store the stamps. There will also be an alert archive where you will be able to extract the full as sent version of an alert, and that would have the stamps in it. PPDB is a catalog, and we don't need to store the stamps in there because the promptly processed images will be available through Rubin's image services. So correct, the PPDB doesn't store the stamps, but it's not like they're not available anyway. They're available in the alert archive, and then the images are available via image services. Fat, I see your hand is up. Let's do a
Yeah, I
challenge.
just posted on the chat as well. I just wanted to know if you know if all the brokers are planning on starting collecting the alerts as soon as we launch them. Um,
Yeah, as far as I know, all of the full stream brokers are headed in the direction of being fully ready. I think the two
cool, cool, cool.
downstream brokers are potentially not going to release their services right away, but I think it's a yes for the full stream brokers so far.
Thank you.
Or that's at least their plan, as we know. It's very challenging, so we might not see them all online immediately, but that's okay. More alerts questions. Okay, great. Hopefully that if you didn't know that alerts were coming, you know that they are coming, what's in them, how to get access, and how to learn more about brokers. That's great. All right, let's get you working on some commissioning metadata tutorials. So together we're going to work through two tutorials. One of them is going to show you how to access the LSSTCam visits database and make very similar plots and tables as I was showing you on this summary page. So it's how to access the data that went into making this summary page so that you can start to figure out, what LSST has been up to over the commissioning phase. And then the second tutorial is going to show you how to access programmatically and via web browser the Rubin schedule viewer, which is the Rubin forecast schedule, which is very important. I know people are planning shadowing surveys and doing other things that require knowing where LSST is going to be looking in a given night. So I'm going to show you how to access both of those tools. Let's start in a new tab by going to data.lsst.cloud. This is the Rubin Science platform. And we're we're going to enter the notebook aspect by clicking on the center panel. I'm going to log in with my own identity provider as you log in with yours. And as always, keep things at the default. We're using the default recommended version of the LST Science pipelines and a large container because we're going to be working with, even though we're just working with metadata today, I'm still going to start up a large container. I'm also going to turn my space heater back on because it's very cold. It's kind of noisy. I don't think you can hear it, but if I start to sound weird, someone let me know. I can't do it without the space heater. Very cold. All right, we're all starting up our pods together, so it takes a minute. All right, this is what you should get to. This is the landing page for the Rubin Science Platform notebook aspect. Just give it a minute, let you all start up your pods and get to this point. It's a little bigger for you. All right, I'm going to close the welcome page because we don't need it today. And from the tutorials drop-down menu, I'm going to click on tutorials in the menu bar, choose commissioning for our commissioning metadata tutorials, and then choose to open the first one, the 101 LSSTCAM visits database tutorial. I have already grabbed this, but I always choose yes to overwrite because I always want the most up-to-date version of every tutorial. So I open that up. And then over on the far left, I'm going to switch my left menu bar from being a file browser to being a navigatable table of contents for my current tutorial notebook. And now we are set up and ready to go. Just pausing in case anyone had trouble finding this notebook, starting it up, getting set up. All right. So this particular notebook is going to demonstrate how to query and load data from a specially formatted file of commissioning visits. This file is also available from the Science Validation Survey Summary webpage. It's this page that I was showing you before. It's the survey visits page, the visits database. This is in particular to the visit database file that's available on this page. And it's the file that has made all of the plots and tables on this page. This is a temporary file. It's a static database file that only includes LSSTCAM visits up to the end of September. It's not a standard schema for our data products. You won't need this file forever. Rob was mentioning, I think the PPDB is coming later this year. So in the future, you would get this kind of visit metadata from the visit and CCD visit tables that will be in the PPDB later. But for now, until that comes, we made this little file for you up until the end of September. We're going to be adding another file that has all of the visits up until I think mid-January. It's just that file is not ready yet, but this tutorial will be updated when we have more LSST visit metadata to share with you. So temporary file, this is a little workaround just to get some metadata into your hands. So the science validation surveys happened pretty much last year between like April and late 2025. This is the same image that we saw on the web page of what LSSTCAM was looking at through last year. And I want to make a few points here that over this time, because LSST was still in commissioning mode, the image quality is quite variable. The AOS system was still like in commissioning. And so these are not necessarily all good visits. All the visits that are in this table are not necessarily all of the ones that will be in data preview 2. They're literally all the visits that were taken sort of in science mode, in LSST mode, but they are not all going to pass science validation. So the eventual number of images that are released in DP2 some of these will be rejected from there. So keep that in mind as you use this file. And of course, the measured IQ values might change. These were measured with very early versions of the science pipelines, using the Summit Quick Look processing, and so also just values might change. This is all just to give you a rough estimate and to get some metadata into your hands. The file itself is SQLite 3 format, and we're going to be using that package to open the file today. So let's go ahead and import some packages to use. Get the name of the file name, define an output path, and define LSST filter names, all sort of very common things to start. The schema for this particular file, I mentioned it's non-standard. It's a bit of an aggregate. It kind of comes a little bit from the consolidated database or the ConsDB schema, which you will also have access to in the future, and the scheduler output schema. So if you have been participating in cadence optimizations and you've been analyzing opsim runs, this schema for this particular SV visit summary database will look familiar, and it's completely fine if it hasn't. A couple of key columns: observation region, target name, the exposure time midpoint, so the MJD, the time, the RA-DEC band, air mass, all the regular observational metadata that you would expect. And then the seeing full width half max and the 5 sigma depth are two measured things about the image that also exist in this file. Richard, go ahead.
Will there be any information indicating wide, fast, deep, or DDF?
Yes, we're going to see that. There
Okay,
is
great.
that. Yeah, coming up. Okay, so we can connect to the file. We're not going to explore the full schema in depth today, but there is a code cell here that can help you learn to do that. You can query the database. The rest of this tutorial just reads the whole, it's not a huge file, so we're just going to eventually read it in. But for large versions of these kinds of databases, you can query and only retrieve rows that you want to. So section 2.2.2 just shows you how to do that. But the whole thing, it's only 81 megabytes. It's not huge. So we can just read the whole thing in as a pandas data frame and then use it throughout the rest. So as you can see, 21,000 rows for this particular file, 21,000 LSSTCAM visits up to the end of September of last year. And I think we're going to answer your question right away, Richard, because kind of the first thing we do is sort of print the unique values of various things like observation region and target names. So these are all observation reasons, which are essentially why that observation was took, what was the scheduler mode at the time. So if you are familiar with these, you might need those kinds of things if you're looking at, cadence optimization or that kind of thing. So for example, here you can print out the number of visits done for the purpose of doing things in deep drilling mode. And I am going to go through this pretty fast because I also want to show you the scheduler viewer. And we're just going to kind of hit the highlights for giving you an idea of what is in this file. So you can get observation reasons out, like the scheduler mode out of this file. You can get target names out of this file. So for example, this is printing all of the small field survey target names. Some of these will look familiar as data preview 1 targets or as targets that were done for the Rubin First Look media event. For wide, fast, deep regions, there's also, so you got the small field surveys. That's kind of the special little areas done for DP1 and Rubin First Look. Then you have various target names related with wide, fast, deep. So this is basically regions of the wide, fast, deep. Either you're in the low dust extragalactic regions, you're in the dusty plain, you're in the north ecliptic spur, that kind of thing. You can get those out of there. The unique target names associated with wide, fast, deep, and how many observations. So for example, extragalactic low dust area had the most number of observations up until the end of September, as you would expect. It's the bulk of the wide, fast, deep field anyway. And then we can get down to the deep drilling fields. This is just the names and the sky locations for the I say 5 because the Euclid Deep Field South, it actually has like 2 adjacent deep field pointings, whereas each of the other ones are just 1 LSST pointing. So the EDFS deep field has an A and a B, and they're right next to each other. So sometimes we just consider that the 5th field, even though it looks like there's 6. And here you can pull out from this file the various names of the deep drilling fields that were covered. You can put that into a list of just unique DDF names and sum up the number of visits that each of the DDFs got up to the end of September. And so this is relevant, of course, because it's these fields that alerts are going to start coming out in. The rest of this particular notebook shows you how to plot basically visit metadata and histograms. The modified Julian dates for each visit with so this histogram is stacked by filter. These are just various ways to interact and just to give you some demonstrations of how to pull out data, the air mass distribution for all of these visits. Very simple visits, very simple plots. Plot of the seeing, which again, we mentioned before, image quality is not where it will be for the LSST survey. These are very early data. AOS was still in commissioning. So do not be alarmed when you see these distributions of seeing. This is not representative of future LSST data. It is just representative of basically the raw, unprocessed commissioning era data. And again, the 5 sigma depths, which of course are going to also be affected by the seeing of the images. And so these are also not necessarily representative of future LSST data, but this is what we will have to work with the commissioning data. And then some summary statistics. So these cells here, we're just making the exact same tables that are on the survey strategy website page, in case those are things that you need. And I think one of the more important or more interesting ones is if you want to recreate that metric analysis framework. That's what MAF stands for. The metric analysis framework has built-in code to very easily reproduce that sky map. And so you can do that quite easily using the MAF package, where you set it all up and then plot exactly the same, basically, as shown on the survey strategy website. So that's what's in this database of metadata for LSS TCAM images that were taken during commissioning. Pretty simple, but we wanted to get metadata into your hands. I'm looking at the question. So go ahead and raise your hand if you want to ask a question about this notebook. And also want to ask if alerts will include DDF wide fast deep tag. Short answer is yes, they're supposed to. I haven't checked the current schema to see that that's in there. I'm pretty sure observation reason is in the schema, but I'd have to look, Richard. And Oh, okay. Fed, you answered your own question. That's fabulous.
I answered one, but not the other, if you don't
Oh,
mind. There was a pairs, and then there is pairs, filter, and a number which corresponds to the time gap between the pairs. But I don't remember what just pairs is. Is that something from the solar system twilight survey?
I do not know.
Okay. Thank you. No
Yeah.
worries.
Yeah, okay. Yes. Suvi's hand is up. Go ahead, Suvi.
So you said the first batch of alerts are going to be coming from the deep drilling fields that were observed. Am I getting this right? During this science commissioning?
Yeah.
So
Yes.
the images you just said didn't have perfect image quality yet. So does that mean the reference images are going to be of poorer quality, so it's not really going to represent the quality of alerts that we'll get later?
I would say probably that's likely true, but there, we also have a minimum standard to create a template in the first place. So it's not like the templates are bad. They are meeting the minimum standards that we have defined in a tech note that I forget right now. So they meet that minimum standard for us to make the templates and to start alert production. But with AOS still being in commissioning, the data will only get better from here. So yeah, I would say they're not bad, but they would obviously be better in the future.
And do you guys ever regenerate alerts using new references, or once you've done a reference, you don't go back?
The I believe the approach for the early science era, and then like especially this year, is once the template is made, we use that template the whole time. We don't want to be switching out templates because then it like changes the alerts and it changes your difference image magnitude, and it's more confusing if we're switching templates. So new templates will be built, but once a template exists, try not to change it on short time scales. In the future, yes, new templates get made from the past year of data. So templates will be updated sort of on a yearly cadence. But that's for the future when LSST is in like full steady state operations.
Okay, thanks.
Yeah. Rob, go ahead.
Yeah, but presumably when a data release comes out, it's going to redo all the subtractions and all the dia source and all dia objects, and at that point it'll use the best possible template for the data release, right?
Yes,
So
because
that's when old detections will get redone subtractions.
yeah, more yeah, on the annual time scale, but we're not during this early science phase, we're not replacing existing templates on short time scales. Isabel, go ahead.
Hi, thanks. It's a really quick thing. So you mentioned a few times about the image quality not being optimal and not the way you expected. Is that so? I was reading the summary of the commissioning and SV. I'm not quite sure if I'm using the right terminology, but and there was a little paragraph in there that said that the image quality wasn't quite what would be needed for the main survey. Is that the same issue that you're discussing now, that like the AO system, the active optics is not quite commissioned yet? Is that the same reason?
I think I don't quite catch the
Yeah,
question.
sorry. So there's a paragraph in the you referenced one of the documents earlier. You actually showed it, where it was a summary of the observations that have been done so far in commissioning. And there's a paragraph in there that mentions the image quality not being optimal. And that I was a bit, yeah, I think it's this document, and I was a bit worried when I read that. But if it's just the thing that you're saying that it's just because the active optics isn't commissioned yet, then that's quite encouraging. I guess I'm just wondering if there's an issue that we should be
Ah,
worried about or not.
you should not be worried, I
Great.
think. Is the main
That's the
takeaway.
right
You should
answer.
not be worried. LSST cam went on. I think it was very, very good, very amazing.
Okay, great.
But this data in particular, like the camera went on in April. These are literally the first images that were taken over the first month up until the end of September. So the image quality was amazing for its time,
Yeah,
but it doesn't match what it will be like in the future.
that's fine. Brilliant. Thank you.
Okay. Yeah, it's not just AOS fed, you're right. It's the louvers, it's the temperature control of the mirror. It's a million little moving pieces. Yeah. Um, Richard, temperature, pressure, computed index of refraction for each pass band versus time in the night. This is not, yeah, not part of alerts. That sounds more like an engineering database question, and I'm not sure of what in your request here is part of ConsDB and not, because we
It,
don't
it's a
have
longer term need. It's not something we need for alerts or targeting, but for the high precision when calibration at some point, that would be useful.
okay.
So if you don't start storing it, trying to go back and recover it, it gets difficult.
Yeah, I do know a lot is stored in the engineering database, like the stuff that you mentioned, but I don't personally use it, and it's not necessarily user facing yet. But as we go on, it would be interesting to hear what you might need out of there and what is in ConsDB. Exposure visit. Yeah, a lot of this is not really engineering, like facility telemetry. So
Who
yeah, we'll
would
have
be a
to
good
see.
person to contact for that?
A post in the forum is really your best start of
Oh,
just
okay.
like, these are the things I need. Do they appear in a user-facing table or not? Is best. Yeah, then you don't have to worry about who to contact. Just put it in the forum and we'll figure it out. Okay, all excellent questions. Yes, there are other data that have looked really nice. End of March, early April is the earliest that any new templates will be made for any region. And in particular, the Rubin first look was like the literally first data that was taken. So I'm not sure that we'll get yeah. So TBD. Small bummer, but we'll see early April what can be expanded on. All right, let's just use the last few minutes. I'm just going to open commissioning tutorial notebook 102. I'm going to open it. I'm going to execute the whole thing by going to kernel, then restart kernel and run all cells. And while that's running, I want to point out that for the Rubin scheduler viewer, so this is the forecast of the Rubin schedule, we have this notebook that shows you how to access that data programmatically. And also I should note it's not just the future, but it has the past schedule as well. So it has the future of what's coming up, but you can also query it and get what did we think we were going to do on a certain date and whether or not those observations were executed. But if you do want to look just at the future and you don't want to use the notebook, there is a browser-based interface to the schedule viewer, which does take a minute or two to load, but it will come up.
Can you post the link on the chat?
Mm-hmm. Yeah. Yeah, so it defaults to the future schedule over the next 12 hours, but this is something that you can change. I'm not going to change it now because making it much longer will just take longer to load, but you can play around with this. And so you can always see what's coming up in the schedule. The programmatic access to the schedule viewer is provided by something called OBSLOC-TAP, which is Observation Locator Table Access Protocol. If you're familiar with the TAP service itself to access Rubin catalogs or other catalogs, OBSLOC-TAP is very familiar. Here, the notebook lists some of the key columns that you can retrieve from the OBSLOC-TAP table for the schedule viewer. And I'm just going to skip down, say you want to retrieve the next 24 hours of schedule. You can do that by setting up a connection with the TAP service and retrieving the future schedule. So this is the kind of data that you need. You want to know where Rubin's going to be looking and what time over the next 24 hours. You can get this data back in tables and use it however you like. You can also retrieve a past plan schedule by defining any time, any date in the past, and then what the schedule was sort of at that time, what the forecast was. You can retrieve that in tables as well, and then you can analyze that predicted schedule once you have the data back. So it's the same format as when you get the future schedule, except that when you retrieve past schedules, there is also a column that tells you the execution status, whether it was performed or not observed. So if you want to go back in time and sort of see what the statistics were like versus like what Rubin thought it was going to observe and then what actually happened, you can get to all of that data through this particular notebook. And I'll just leave it there. I just kind of wanted to show you what it looks like to get to these particular services. And I am happy to take a few quick questions. Oh, did I put the wrong? I did. Because I didn't. Yeah, thank you, Fed, for noticing. Yeah, so both of these services are here for you. Happy to take a question. Yeah, Dave, go ahead.
So do we really, the way I take this is that we have access to the predicted schedule in the next 24 hours, but not some kind of longer term, say month-long schedule or anything like that to plan ahead.
Actually, I don't know. I think you can do longer than 24 hours. I just didn't.
Okay.
And I haven't tested how much I can ask for at a time, actually. We should test that. I think I've tested at least 48, but like if you wanted a week or something, it will take a while to churn away in the background, but I'm not sure of how long. Is anyone here from survey scheduling and know when they make the future schedule? Is it a week? Is it the whole year?
I mean, the OPSIM, the OPSIM has the plan, but I don't know. I don't think it would be wise for us to enable people to fetch the plan for like a distance future because it's not a meaningful, it's not a meaningful plan.
Yeah, it is. Yeah, that's true. It's probably only accurate for a few days.
Yeah, that's true. I would say like for a week, it's good. Some of us are trying to arrange observing to kind of fill in the gaps of the WFD. And it's really hard to do on 24 hours notice. It's really hard to do on a week's notice, but a week is a little better than a day. I understand it's very early days. Just asking what's available. That's all. Yeah.
Yeah. So I don't know how much future you can grab, but I would say that any more than a couple days in the future the accuracy is going to drop, and I don't know by how much. All right. Thanks for being here. I'm going to stop recording. I hope this was useful. If you have questions, just get them in the forum, get them back to us. And yeah, happy sciencing out there, everybody.
Thank
Thank you,
you.
Melissa. That was great.
Thank you.
Thank you.
you.
Thank you.